Hello everybody, welcome to Grade 12 Paper 1 Winter School. In this video, I analyze the syllabus and give you some strategies to help you with your studies. I also discuss the November 2020 Paper 1 Question 7 in full, and I take you through the explanations as well as how the examiners mark and where marks are allocated. Calculus is divided into three parts. First, there's the first principles and rules of differentiation. That's one question. Number two is the cubic function. And then lastly, the third question is the calculus application. Now you will see that 35 out of the 150 is reserved for calculus. This question counts 12 out of 150. Can you remember I said if only you could score full marks for question 1? That one was worth 14%. That was question 1. Plus the 8% here. Can you see you are already on 22% for paper 1? Calculus is a topic where you can definitely score easy marks, especially this question. Let me show you. Now, as you can see, 7.1 determine the derivative from first principles, and then 7.2, both of them are rules of differentiation. Now, again, there's also a playlist on calculus where I explain everything in detail. You will find that playlist on the home page. Let's do the question now. 7.1. Determine the derivative from first principles if f of x is 2x squared minus 1. When we use the first principles, the formula that we use is this one, and it's on the formula sheet. Remember, don't make a mistake when you copy this one. Now, the first thing we need to do on the right-hand side here is we have f of x is 2x squared minus 1. And we want to substitute in fx plus h. So my advice to you is do it on the right hand side there and get an answer first. When you are going to substitute x plus h in x's place, that's what you get. And then the first thing you do is you wait with the 2 and you make 2 brackets with that x plus h and you FOIL it out. And after that, now in goes the 2 into all three terms. And there's no like terms that you can add. So that's the answer. So back into your sum over here, in the place of f of x, you substituted that whole 2x squared plus 4xh plus 2h squared minus 1. And then there's the minus from the formula and a bracket f of x, the function as it was given to you. And then in the next step, you're going to multiply in this minus. When you multiply in the minus, you get that. And then you check if there's like terms that you can add. And there's this 2x squared minus 2x squared is nothing. Minus 1 plus 1 is nothing. Then in the next step, you have that. And now this is where you're going to factorize by taking out h as a common factor. And then in this step, you took out h as a common factor. And now you're going to cancel the two h's. In the next step, everywhere where you see an h, you're going to substitute 0. The limit h tends to 0. So in h's place, in fact, there, I'm going to substitute the 0 and the final answer, the derivative is 4x. And then where's the marks? The marks are here where you did your fx plus h. In this step over there where you ended with 4x h plus 2h squared over h, and then also your substitution, the substitution was there. Here where you factorized by taking out h as a common factor, and then final answer. 7.2, determine d over dx. That means find the derivative. But just to remind you, you cannot find the derivative if there's brackets. You first have to, say for instance it was bracket squared, then you have to multiply out the brackets. You cannot find the derivative if there's an x under the line, so this one you will write it as x to the negative 1. And then the last one is you cannot find the derivative if there's surds, roots like that. You have to write that as x to the power of a half. So let me just show you. There by the x, the exponent is invisible 1, and then there by the root there was an invisible 2. And can you see this 2 becomes the denominator, and this number there becomes the numerator. So back at our sum, we have a problem, and the problem is this surd we have here. So we're going to write that one as x to the power 2 over 5. And can you see, this is what happened. The 5, the type of root, became the denominator at the bottom, and whatever was the exponent is the numerator. And then please note, can you see that the notation is still d over dx, because I have not I haven't found the derivative yet. I'm going to do it now. Now that I'm doing it, it falls away. So what happened? I took the 2 over 5 to the front, and then on your exponent you subtract 1. And here, the other term, there's the 3, the exponent, it goes to the front and you subtract 1. And then in fact that's the answer. So the only thing I did here was I said 2 over 5 minus 1 with my calculator is minus 3 over 5. And then where's the marks? The marks are here where you saw this whole surd was x to the 2 over 5, and then 1, 2 final answers. And then with this one you can leave it there, but let me show you. Perhaps the question will say, and leave your answer with positive exponents or positive indices. That's the plural for index. Then let me quickly show you how to do that. So what you will do is you will take the x to the denominator, and then this minus 3 over 5 will become a plus 3 over 5. And then even this one you can take it further if you want to, and you can say it's the 5th root, and then there's x to the 3. But all of this step and this isn't necessary in the sum because they weren't asking for it. 7.2.2, determine the derivative if f of x is 4x squared minus 9 over 4x plus 6. And then you also find this little bit here. It's a restriction where they say x is not equal to minus 3 over 2. Now, don't be scared. What it means is it's because there's a fraction there, and then you cannot get a 0 under the line. So they said 4x plus 6 is 0, 4x is negative 6, divide by 2, x is negative 3 over 2. That's where they got that from. But just ignore this. It's got absolutely nothing to do with where you're going to get marks from. All right, back to finding the derivative. We cannot find the derivative with this 4x plus 6 under the line. So what you're going to do here is at the top on the numerator, that was the difference of two squares. So I wrote it as 2x minus 3, 2x plus 3. And at the bottom, I factorized by taking out a 2 as a common factor. And please note, can you see here on the left, it's still f of x. Don't write f dash x yet, because you are not finding the derivative yet. Then in the next step, I can say 2x plus 3 will cancel out, and I'm left with 2x minus 3 over 2. Now this is not nice because first of all you have to separate this 2x minus 3 over 2 into two terms, and then here the 2 and 2 will cancel each other out. And the sum that I'm actually going to find the derivative of is now f of x is x minus 3 over 2. Now I can do it. How do I find the derivative? There is an, let me show you, there is an invisible 1, and then the 1 goes to the front, which is in fact that one. And then here, I'll do it here for you. I have a 1 and then I subtract 1, and then x to the 0 is 1. And then it's this 1 in front there that I have. So 1 times 1 is 1. So that's why this derivative is 1. And what happened to the minus 3 over 2? Remember, the derivative of a constant is 0. And then where's the marks? The marks are here where you saw that was the difference of two squares, where you pulled out or factorized, pulled out 2 as a common factor, where you made this into two separate terms, and then when you found the derivative. 4 marks.
The next question that I will discuss is also based on calculus, the cubic function. Click on the video in the left-hand corner to take you straight to that question.